what is apparent charge part 2? So let's imagine I'm having my high voltage setup and I still have my coupling capacitor here. That's my coupling capacitor. This is once again my low voltage capacitance. This is my quadrupole, and I'm going to connect my measuring instrument to it. And now I want to test the cable. And in order to test the cable, well, I have a conductor inside and the outside. So let me connect the high voltage part, and now we're going to connect the ground to my setup. So that's already a really good start. And now let's imagine we are going up with a voltage, and we're going to have a partial discharge in here, inside the cable. So the partial discharge, let's say, will be somewhere around here. Once again, we know, I mean, now it's pretty obvious, that the whole cable is actually a huge capacitance. This is a capacitance, and that's a capacitance. So now, if we have a partial discharge in here, what is going to happen? How is the charge transfer going to happen? Will we only have a charge transfer from here, or will it happen inside as well? So now let's imagine it's a 100 picocoulomb partial discharge. As a matter of fact, we don't even know that, but let's imagine it's a 100 picocoulomb discharge. What is going to happen? We're going to have a charge loss here, and this capacitance will recharge, and this one, and I mean, obviously, you're getting the idea. And now, after all of these are recharging the missing charge, and only a portion here is allowed to go in here. The problem is, this is the only current that goes through my quadrupole. So this is the only one I can measure. Thus, I never really know how big the partial discharge inside my test object is. So I could have drawn a transformer here as well. A transformer, same thing. We have windings, we have an outside wall, we have the other windings, we have huge capacitance inside a transformer as well. So we never really know what kind of discharge we had. If you have a really small setup, like a really small one, and you only have a, let's say, an outside partial discharge on a corona, maybe the measured partial discharge is rather close to your apparent charge, to your real charge. So the one that we measure, this is apparently the charge. So possibly your apparent charge is almost as big as the real discharge. But we don't know. Especially if you're talking about internal discharges, especially if you're talking about big objects with a lot of capacitance, and especially if this capacitance is much bigger than the normal capacitance of a coupling capacitor, then we are definitely having the charge that we are able to see on the outside, and this is how we usually define it. We have a partial discharge on the outside of our test object. This is where we connect with the connection clamps of our testing, of our partial discharge testing circuit. We are getting an idea, we're getting a signal, and we call this apparent charge because the real charge is unknown to us. By the way, in order to have an idea how big the apparent charge is and how big the real charge could be, we have to calibrate, but that's a different topic. So we're not going to talk about this right now. That's going to be part of another video, and most likely this one. So, thank you very much for watching, and hope to see you soon. Bye-bye.